All right, so here we've got the notes for section 4.3, which deals with the derivatives of the inverse trig functions. So down here we got our lovely definition. So if f is differentiable at every point on the interval I, and f prime of x is never 0, then f has an inverse, and the inverse function is differentiable at every point on the interval I. If f prime of a is equal to b, the inverse function slope relationship relates the derivative by the equation. The derivative of the inverse of a over b is 1 over the reciprocal of the derivative at b. So that's your fun definition. So here's our formulas. So arc sine is the same thing as the inverse sine, sine to the -1. So here's our formula. This is in terms of x. Down here we have the more generic chain rule version, because it may not always just be the inverse sine of x. There may be something like an x squared, a 2x plus 1, things like that after the sine. So here's our formula. So it's 1 over the square root of 1 minus u squared. And then you have du dx here, which is the derivative of whatever follows the sine. So it takes care of the chain rule part of it. So this part here is actually the derivative of the inverse sine. This part here is the inside part of the chain rule. Now, u has to be, the absolute value of u has to be less than 1, because the inverse sine function cannot be evaluated if u is more than 1 or less than -1. So that's why you have this restriction here. All right, so for example 1, find the derivative. So this x squared is going to be our u value. So the formula is 1 over the square root of 1 minus u squared, so that's going to become x squared squared, and then times du dx, which is going to be 2x. So simplifying this, so y prime equals 2x moves to the top, square root 1 minus x to the 4th, x squared squared, you multiply the exponents, there's your answer. So we got the arctangent next, so the inverse tangent function. So here's our rule for inverse tangent, 1 over 1 plus u squared, and then once again du dx for the chain rule part. So example 2, a particle moves along the x-axis so that its position any time t greater than or equal to 0 is given by this equation. What is the velocity when the particle in t is 16? So let's rewrite this guy first. So x of t is equal to the inverse tangent of t to the half, just to write it in terms of powers. So here's our formula. So x prime, the derivative of our x equation, 1 over 1 plus, so our u value is the t to the half, and then squared, and then times du dx, which is the derivative of the t to the half, so that's going to be 1/2 t to the -1/2. Now, since I took a derivative of a position equation, this is actually my velocity. It tells me here when t is 16. So all these t's become 16s. I'm going to do a little bit of cleanup first. So v equals 1 over 1 plus, so t to the half squared is just t. So we have this. So now t becomes 16. So 1 over 1 plus 16 times 1/2, 16 to the -1/2. So v is 1 over 17 times 1/2. 16 to the -1/2 is actually 1/4. So it look like this. So my velocity is whatever 1/17 times 1/2 times 1/4 is, which is 1 over 136. All right, arcsecant comes next. So this is the inverse secant. So here's our formula, absolute value of u, square root u squared minus 1, and then du dx for the chain rule part. So here, so that part's going to be our u. So y prime equals 1 over the absolute value of 5x to the 4th, square root of 5x to the 4th squared minus 1, and then times 20x cubed. So let's see if we can clean this up a little bit. So this is going to be 20x cubed over 5x to the 4th square root 25x to the 8th minus 1. So obviously squared goes to the 5 and to the x to the 4th. This can be reduced, so this is 4 on top 20 over 5. This x cubed cancels 3 of those out, leaving me just x. And 25x to the 8th minus 1. Now be careful, oops, fraction bar. Even though 25x to the 8th and negative 1 are all perfect squares, you cannot take the square root because that's not how the square root function works. So don't do it. The reason the absolute value bars can drop here is that 5x to the 4th will always be positive. So I can disappear them because x to the 4th is always a positive number. Positive times 5 will always be positive anyway. All right, so down here at the bottom, the derivatives of the inverse functions are negatives, with the derivatives of the the derivatives of the inverse cofunctions are the negatives of the corresponding inverse function. So cosine, the inverse cosine, is -1 version of the sine. Cotangent has a -1, where tangent would have a +1 on top, and cosecant would be -1 on top. That's all that means. So we can write them down here real fast. So the derivative of the inverse cosine of u is equal to -1 over the square root of 1 minus u squared times du dx. The derivative of the inverse cotangent is -1 over 1 plus u squared times du dx. And lastly, if I can fit it in here, of the cosecant is -1 over the absolute value of u square root u squared minus 1 times du dx. So just this equation with a -1 on top instead of a +1, because they are the negatives. Okay, and just a couple of calculator identities if you want to use it. So example 4, find an equation for the line tangent to the graph of this at x equals -1. So we have our x value. We need our y value. So to do that, we plug -1 in there. So the inverse, so that's the inverse cotangent of -1. So we can now do that with this formula. So it's pi over 2, because our calculator doesn't have cotangent. Especially doesn't have inverse cotangent, so it's going to be pi over 2 minus the inverse tangent of -1. So this is, I'm finding my y value. So the tangent is -1 when the angle is pi over 4 and negative pi over 4. Sorry, just negative pi over 4. So look like this. So that's pi over 2 plus pi over 4, which is, so there's my y value, 3 pi over 4. And then to find the slope, I need to do the derivative. So m is equal to y prime is equal to, so the cotangent is -1 over 1 plus, so my u value is just x, so x squared, and then times 1 technically, because du dx is derivative of x, which is just 1. So my x value is -1, so -1 over 1 plus -1 squared is -1 over 1 plus 1, -1 half. So my equation, y equals m x minus x1 plus y1. So y equals -half x minus 1/2 plus 3 pi over 4. And that's about as good as you can get it. I suppose you could combine the fractions. So that's 2/4. So plus -2 plus 3 pi all over 4, if you wanted to write it like that, but that doesn't really get you anywhere. That one would be just fine. But that brings us to the end of the section.